Good evening, everyone. It's 5:40. What are you doing here? You're not out to grab a beer. Instead, you come to a security talk? Are you crazy? I wouldn't do that myself. Hi, I'm Daniel. I work in the Spring team. My focus is on Spring security. So anything Spring security itself and security-related stuff, such as authorization servers, SAML, and so on. And I also do a little bit of a commercial products, a package, applied Spring, right? I take Spring libraries and then build products that we sell to our customers. Here are my socials. You can find me, Blue Sky, Internet, GitHub, email, also LinkedIn. There's one of me with that name. People tend to look me up on LinkedIn and find me. The reason I come to these conferences is to meet you, to get feedback from you, like to learn what you do, learn from your use cases. So feel free to reach out, interrupt me when I'm in a conversation. I'm here until tomorrow. If you're on YouTube, sorry you couldn't be here, but like, subscribe, and shoot me an email. I'll be happy to chat with you. So the topic of today is passwords, or lack thereof. So it's 2025. I probably don't need to give you the whole spiel about passwords are bad. You can see I have great passwords myself. I put them on sticky notes and then stick them under my keyboard, very secure. Also, I reuse them across websites. Terrible, terrible. So don't use passwords. It's, I guess if you're here, you're convinced. We've been able to do login without passwords for a long time now. Do you know how we do this? Any idea? Sorry? That's why you're here. Yeah, well, we have the new cool thing, Passkeys, but you've used that. I'm sure you've used that before. On websites where you have an account, you can do usually one privileged operation without your password. Forgot your password. Correct. When you don't have your password, you're not going to log in with your password. So what do? You do one-time tokens, one-time links. So it generates, you go to the website, put your email or your contact info, and then it sends an email with a link that you can only use once to reset your password. And so this, you can do in Spring. So it's been here for 6 months now. We support for one-time tokens for passwordless login without all the new fancy stuff. And it's fairly easy. So I have a simple Spring app, and it has security in it, right? And then I can log in with daniel@example.com and put some very secure password, and I can log in. I'm going to do it here, so this one doesn't complain. There we go. So if we want to do passwordless login on this app, it's fairly easy. You go to your Spring security configuration that you've configured. So my current app does form login, username and password. And I say, no, I don't want this. Instead, I want one-time token login, OTT token, let's call it OTT config. OTT config. And then I need to configure something, because this will set up everything I need to generate tokens when users want to log in, to validate those tokens, store them, and so on. But then I need to pass those tokens to my users. So I need to configure that thing. So when a token is created for a user, what do I do with it? So the thing we have is OTT config dot handler, the success handler. So when a token is created, what do you do? So it takes a request, a response, and it takes a OTT token, let's call it, right? So if you want inspiration, we have a default one. Hello. Yeah, okay. I think intelligent, yeah, fine, all right. So we have the a redirection thing, redirect one-time token handler. So we say, well, when someone requests a token, redirect them to a page. So say login OTT. So we can make this a field. Let's call it default OTT handler, right? And then with this, we do default OTT handler, handle request response token, right? So just a redirection and in the field. Then we need to pass the token to our users. So we're going to console out so we can see it. And let's put, I don't know, a key. Yeah, that's good. Login attempt for some user and use token blah, right? And so that's not the remote address. What we want is the username of the user that's trying to log in, or maybe their email, and then the token value that they should use to log in. And these are in this OTT token object, right? So there's a username, the email of the user, and then in the OTT token, there's the token value, right? And that's it. That's all you need to enable one-time token login. In real life, you're not going to print these tokens to your console because your users don't go to your backend and like read your logs to get their tokens. So you will have your own notifier thing. So I have this one-time token mail notifier to send emails. So I notify the email, and then a title, login to Devox UK demo, and then some tokens, so the token value here, right? So this you will implement. Maybe you send, text messages. Maybe you send emails. Maybe you do notifications. I don't know, but that's it. With this, let's recompile our application so that it takes these into account. So after a little while, right, request a one-time token. So I can put my user account, daniel@example.com, and it generates a token. So it should be in the console in here, right? So there's the token I should use. Or I have a local SMTP server that I can use to read my email, a real email client. So I got my email, your one-time token, and then I can click on this link. It brings me to this page. I can sign in, and boom, I get logged in. If I log out of this, and then I go to the submit page again, the one where I can paste my token, if I copy this token here and sign in, of course it blows up because it's a one-time token, not a two-time token. And so it's a lightweight way to do passwordless login, which is great and fun and good, but you don't come to Devox UK because you want me to show you 1998 technology. You want cool new stuff, you want passkeys. So these passkeys, who knows here what a passkey is? Like, know how it works? Ooh, 10 shy hands. And who actually uses passkeys? 1, 2, 3, 4, 5, 6, less than 10 people. So it's an interesting thing because it has existed for a while. I think Apple coined the term in 2018, 2019, something like that. And even in a developer crowd, there's less than 10 people in the room actually using it. So I want to show you how it works before we go into the implementation. I use that every day for many, many services. So let's go to GitHub on my private window here. Boop, boop, boop. And then I'm going to put this to the side, make this bigger. And then here is my phone, mirroring, right? So you can see my fingers. You should be able to see yourselves. Hello. And so I can sign into GitHub. And to do this, I could put my username, git@garnier.wf, then my password. But if I do this, I need to do two-factor, so maybe grab my authenticator or something. Or I can click on this magic button, sign in with a passkey. A dialog comes up and says, you will be signed in to github.com using your username, Carlan here, right? So I take my finger, I have to zoom out so you can see it, right? Put the finger on the fingerprint reader here. The Mac unlocks a cryptographic private key, makes a signature, sends that to GitHub, and then GitHub validates that it's me. And so in one operation, I've done two-factor, right? I've proved I possess this Mac that contains the key, and I also use biometrics. So I proved I am something. I did two factors. That's one of the ways of doing passkeys. You can also do with, if you don't want, if say your device doesn't support that, you can use external things. So here's in here, this one that blinks here, this thing. This is a Yubikey. I can put it inside and click on it. I need to enter a PIN so that if you go after the talk and assault me and like steal my Yubikey, you can't log in because you need my password. So same thing, right? It's doing cryptography on my behalf, logs me in. Also, you can do that with a password manager. So if you're on Linux, it's not as well supported as Windows and Mac. So in here, I also have a passkey in 1Password. And this one pops up and it says, oh, do you want to use your passkey? Sure, I use my passkey. Boom, logs me in. And the last one is my favorite one. Let's put the video again. So I can log in someone else's computer. Say I have a public computer in a library, and I want to log in with a passkey. Sorry, I have to. This is very important, right? I'm working on my speaker portfolio images. So I can do sign in, and imagine this is a public computer. and I don't want to like plug in my Yubikey. So I can click on sign in with a passkey. I can click on other sign-in options here. And this one says sign in with an iPhone, iPad, or a nearby device. I say OK, continue. And it shows me a QR code. So now this computer here is public. I take my phone, my own phone. I can point at, sorry, my bad. Point at the QR code, click sign in with a passkey. The computer and the phone are going to start talking with each other, right? And so on my phone, I'm going to say, yes, use a passkey. It's going to do the cryptography on my phone, send a signature to the computer, and then the computer can log me in. So with this, sign in with my face, and then boom, I'm logged in, right? Even though there's no crypto that happens on the computer, right? So pretty cool. Yes? So phishing method is this not the easiest way to steal someone's password with a QR code thing. So we're going to discuss a little bit these passkeys and the security features they have. One of the features is that a passkey, it's a private key, and it's generated for a given origin, so a domain. Right? So if you send me to github.com instead of github.com and then try to steal my private key, the authenticator, my phone, my Yubikey, is going to refuse to sign anything because it doesn't have any passkey that's been created for that domain. So it's phishing resistant. It's not like I can go and type my password in the wrong domain. This one, the device is domain aware. OK, so this is how it works. In passkeys, we've mentioned a few terms. I want to clear them up a little bit. So a passkey is a cryptographic credential. It's a private key with some metadata associated with it. And it's tied to my account on a website. So on GitHub, when I want to add a passkey, I go to the settings here, right? And then I go to password and authentication. And there's an entire section called passkey, and you can go click here and add passkey. So you can have multiple devices you use to sign in, my 1Password, password manager, my Mac, my Yubikey, and so on, right? So the passkey is the credential. The authenticator is the device or piece of software that holds that credential. It's 1Password, it's my Yubikey, it's my phone, my laptop. Sometimes you may hear them referred to as FIDO keys. So FIDO stands for Fast Identity Online. It's an alliance. You know, the big names started it, Apple, Google, Microsoft, but we have many, many more players now. So, you know, banks and security companies and, I don't know, Netflix. So huge consortium. Everyone wants this easy to sign in feature. And they work on two specs. So they work on WebAuthN and CTAP. CTAP is client to authenticator protocol. It's for when you're building the Yubikey or the browser that talks to Yubikey. So for us app developers, that's not really something we will look into. The second spec they work on is WebAuthN. WebAuthN is the spec that controls how your browser can interact with passkeys, get private keys, generate signatures, and so on. So it's a beautiful W3C spec with all the trappings of delightful W3C spec. It's something you really want to see at 6 p.m. So it has, you know, typing, complicated typings, a lot of, you know, descriptions, and then if you scroll far enough, some code, and probably some diagrams. I don't know if I can scroll far enough. Oh, diagrams, yeah, beautiful. And so this is pages and pages and pages and pages of complicated security, 216 pages. Not great. You don't want to be reading this, right? You want to be a user of that. And so that's why we bring support to Spring Security, so that you don't have to try and go and understand what is going on in this thing. You're going to be a user of WebAuthN, not an implementer. OK, so these passkeys, how do they work? I mentioned cryptography. So instead of having a password in my brain that I can reuse, passkeys is about generating a private key for a website, so a new private key for every single website. And so we're doing asymmetric crypto. So the basic, like most of you probably know how asymmetric crypto works. So say we have Alice here. She can generate a private key and a public key. These are linked, right? So she keeps the private key private. Incredible. And then the public key she can distribute. So when I go to github.com and I click register a passkey, it's going to create a private key on my device and then send the public key to GitHub. And the cool thing about these things is that now, using a private key, Alice can prove that she was really the originator of a message. So she wants to sign some content. So she has any byte array that she wants to sign. Using a private key, she can produce a signature, another byte array, and then she distributes the content and the signature. Anyone who has the public key can verify that the signature matches the content that was sent. So this is what you have in JSON Web Tokens as well. So JSON Web Tokens is signed. Usually you have the public key of the entity that produced the token. So that's what's happening. If an attacker tries to impersonate Alice, they don't know the private key because she kept it private, so they have to come up with like another signature. But then if they come up with a different signature, the public key does not validate the signature anymore. It says, well, it wasn't generated with the associated private key. This is what it does under the hood. And so how is this used? Well, there's two phases of this Passkeys interaction. The first one is registering a passkey. So I go to github.com, I log in using my one-time token, my password, my two-factor, whatever, and I register a new passkey. So an authenticator is going to generate the key pair, private key, public key, store the private key securely on the device, and then share the public key with, say, GitHub here. So with the website I want to authenticate against later on. The private key, as we said, is for that website and nothing else. So the authenticator will refuse to use the private key that created for GitHub to use it on, I don't know, google.com. So now that my passkey is on the website I want to log in, I can use it to authenticate. So I come back to github.com, I say sign in with a passkey. The authenticator is going to take some challenge that GitHub sends me, produce a signature, and then send that signature back to GitHub. GitHub loads my public key, verifies the signature according to the challenge, and then says, okay, I know this is Daniel. It matches, the signature matches, so I can log them in. So for you to visualize the flow of how this works, you could go to the spec and try and decode these beautiful diagrams that start at level 0. And, well, everything is correct, but it's a little bit hard to parse. So a simplified model of interaction. So I'm going to go to github.com. I click on sign in with a passkey. So github.com is going to generate a random challenge. So something that is going to be used only once. This allows me, when I produce a signature, if someone sees that message and like in the log somewhere because they did something wrong, they can't replay the message because at a different time I would have a different challenge that I need to sign. Then this is passed to the browser, and the browser is going to call a browser API called credentials create. So create a passkey for this website using the challenge that was passed in and a bunch of options. This wakes up any authenticator that are around or connected or nearby. These authenticators, I select which one I want to create a passkey with. So maybe click on my Yubikey or like scan the QR code with my phone. The authenticator will start telling me that I want to register a passkey. So it will prompt for some sort of verification. I need to be at least present. So I need to click a button, make an action. The user must be there to avoid having passkeys created behind your back, for example, on a website that you don't trust. So at least you prove you're present. Maybe you also put some sort of PIN, some biometrics to verify your identity, to lock, right? So if you steal this key after the presentation, if you don't know my password for the key, you can't use it. If you steal this one, there's no password on it, but it doesn't have passkeys registered. So, but this one still blinks, and I still have to click it. So I click, I say, yes, I want to create this passkey for the website. And so the authenticator, the Yubikey, the phone, generates that key pair, stores the private key, and then signs the challenge that was passed in originally that was created by the server. So this challenge here that was passed here. And it returns the public key associated with the private key, as well as the signed challenge. So then you're going to write a little bit of JavaScript here that is going to be sending the public key and the signed challenge back to the server. Here, right? It sends this to the server, and then the server now can go and validate that, okay, you sent me a signed challenge. I know which challenge I sent you, so this should match the signature here, should match the challenge using this public key. If they match, that means that you have the private key that corresponds to that public key. So I store it. I put it in my database, and when you come back, I can log it. It's a lot of steps, and it's a bit scary, but as a Java developer doing a website, you don't have to care about anything that's right of this line. Right? This is not something that you do because, well, the users, you're not implementing your users. I think, unless you're doing, LLM-powered human beings. Authenticators, I don't think you're building your iPhones or Yubikeys. So you only care about anything that happens in the browser or on the server. So I know this is a Java conference, but unfortunately, you'll have to write a little bit of JavaScript. So anything server-side, you would do Java. So in this case, we're doing Spring Security, so that's Java. Very well supported. There's not much you need to write, right? The defaults we give you work. They're fine. They're nicely packaged. The JavaScript, in the Spring team, we're not in the business of writing JavaScript. I almost got an award for accepting to write JavaScript. So we have an example. We have a page with the JavaScript that works that you can use. It is not a library. We don't provide you a JavaScript library to interact with the backend. This is for you to build if you want your own custom interactions. But we have a template that works that you can base your work off of. OK, so that's the registration. The authentication phase is exactly the same thing, but instead of calling credentials create, we call credentials.get. Instead of generating a private key, we load the private key for the domain and do the signature, and we only pass the signature to the server so they can check it. But exactly the same interactions. We call some JavaScript function here, and then we send the return value to the server who can then verify this. Cool? So far, so good? No questions? Can this challenge be, sorry? So yes, the challenge could be stolen, but then what would the attacker do with it? Right, so an attacker could intercept this request here, right, and make their own signature here. But then if the server validates it with my private key, or my public key, sorry, anything they generate with their own private key doesn't match, right? Right. So they could register their own thing, but they have to be present, validate the private key. Like, an attacker could be in your browser here and hijack everything, but it probably means you have questionable security policies in your, you're not setting CSP headers, you're not doing state-of-the-art protection, but like it's the same as if they were in here and like saw your password go in, right? And they could steal your password. So the same threat model, if you will, as a username and password submitting stuff. Okay, so before we go into implementation, one thing that I want to reiterate because it's not super clear. Sometimes I get people at conferences that tell me, but I don't want to send my biometric data to GitHub or to Google, right? Passkeys are not biometric. They have nothing to do with biometrics. They're just a random private key generated and has some metadata associated to it. And that's it. They're stored in an authenticator. So a physical device, such as a phone or a password manager. And it so happens that to unlock this device, I sometimes am able to use biometrics. So to unlock my Mac or to unlock my iPhone, I can use my FaceID, TouchID, whatever. But it's just for unlocking the thing that holds the keys. It's not the keys themselves. What GitHub gets is just the public key here. No biometric at all. Sometimes these keys, they're synced to the cloud. So if I use a password manager, or of course, my password manager syncs the private key across my different devices that use the password manager. If I use the iCloud keychain, it syncs the passkeys across devices. But this has nothing to, GitHub doesn't have to know about this, doesn't have to care about this detail. Yes? Right, so Exactly. So the question is, if I have multiple Passkeys registers, I have multiple users that have multiple, each that have their own passkey, how can they select that? So you have multiple flows. You could be sending the username to select the passkey, but the passkey also has an ID. So you can select by ID, or like it's not the passkey itself, it's the public key. So when you sign something, you send a challenge, and you say, I sign it with a key with that ID, and should match in your database the public key that matches that. So the finding the right thing is usually fairly straightforward. And you don't have to care too much about it, because Spring Security does it for you. So let's see how we do this. Enough blah blah. Let's code. So since this is a complicated thing, and I want to do a new thing, I go to Josh's third favorite place on the internet that he never talks about. Can you guess what it is? Of course, it's docs.spring.io. Hey. So let's go to the Spring Security docs here. You will find everything you need. So you can click here on the search bar, look for Passkeys. And then in here, there's all the documentation you need to get started. So, here's the minimum config you need. Here's the, if you're doing your own front end and you need to know what type of data you need to pass, well, you have all the details in here. But just to get started, it has required dependencies here. So you need one required dependency, so Spring Security Web, the basic Spring Security, and also WebAuthN for J. So WebAuthN for J is the thing that does the heavy lifting on all the crypto verifying, that all the different possible attacks you could do with a passkey. We don't want to re-implement that crypto, so we trust them to do that. So let's pull this dependency in our build file. Yeah, all right, implementation, and let's come on, this one here. Okay, so reload. I'm going to restart this once it's reloaded. Come on. I know it's 6 p.m., but you can do it. I trust you. Trust you. All right. All right. All right. All right. Yay. There we go. I was out of Zoom. So great. So restart the application because I have a new dependency. And then in the meantime, we can set up our security configuration to support Passkeys. So Passkeys is WebAuthN, right? And in here, let's call it passkey config. So there's very few things you need to configure, but you need to say at least 3 things. So the name of your app, let's call it Devox UK Spring Passkey Demo, right? Then you need to put the RP ID. So RP in Passkey is relying party, it's your website. And the ID is the domain. So if your site is at, I don't know, daniel.example.com, you would put that here. This avoids the phishing of Passkeys. Right? It can only work on one domain. So my demo is on localhost, so I put localhost. And the origins, allowed origins, because it's actually, you can access that under certain conditions from subdomains, or if you have multiple ports, or you have one over HTTP over HTTPS, you're going to allow only certain combinations of those. And then that's it. If you do this, and you go to, let's put it here, localhost 8080, it's reloading, and now I have a new button, login with Passkey. So if I click here, it brings me the Passkey dialog. So I could go and start doing logins. I don't have a pre-registered Passkey for a user here, so I cannot log in. I need to register Passkey first. When I said this is enough, this is kind of a lie here. This is all in memory. Scream. Ooh, Scream? Scream, right? So Rob Winch, the lead from Spring Security, says it's not real if it doesn't have at least a JDBC implementation. So in 2 weeks, Spring Security 6.5, Spring Boot 3.5, we will give you that JDBC implementation. The problem here is that the private key is generated once on the device, the public key is shared once. So if I lose the public key, I cannot re-register the same passkey. I would have to generate a new one. So you really want to store them in a database. So in here, you need to provide a few things. So we assume you have users, right? Because your users are using a login, or like they're using Passkeys through login. So we assume you have some sort of user details table or user table, whatever you want to do it, and they need to have a username or user ID, something to identify them. And you need 2 tables for these Passkeys to work. One is the user credential record, which contains basically the public key. and then some metadata associated with the key. So you can see, oh, this key is named, I don't know, MacBook or whatever. And then an association table that links a passkey with a user. And then that's it. So you need these two repositories, which now you don't have to implement manually anymore. So there's a user credentials repository. Let's call it passkey repo, right? Return new JDBC user credential repository. My IntelliJ is a little bit slow, but with the magic of IntelliJ, you pass it a JDBC operations. So the JDBC abstraction to write to the database. And then one more, the public key credential repository, user entity repository, because we're writing Java, right? Public key credential user entity. It doesn't have factory in it. Passkey to user repo, pass JDBC operations, and then return new JDBC something something JDBC operations. And then that's it. With that, your passkeys are stored to the database. So now, while we're at it, I can now go back, sign in, example.com. I need my token, localhost 1080, right? Yep, click here, beautiful, sign in. And so in here, you want to provide users with a link to register their passkey. Is this called index? Yes, perfect. No, go away. Sign in with a passkey using Spring Security, and then you probably want to wrap this. What happens if I do this? No. Okay. And the link, the default registration page we have is WebAuthN register. Or you can write your own if you want. Okay. And now, reload, perfect. And so this is the page for registering a passkey. So I'm going to put this to the left here, bring this one up. And so now I can give the name to the passkey so that the user can know and manage them, maybe delete them if they don't want to use a passkey anymore. Click register. It brings up a dialog and says, a passkey for the user Daniel@example.com will be saved in iCloud. Do you want to do this? Yes. Sure. So biometrics. Private key generated, stored on my Mac. Public key sent. So I could do that as many times as I want, right? I can do status here. This one is like a physical security key. Maybe, okay, whatever. So, or I could register my phone, but doesn't matter. So if I log out now and I click sign in with a passkey, it brings the dialog again, and it says, you will be signed in into localhost using the account you used. So again, boop, 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 finger, touch, and boom, I'm logged in, right? So no more passwords, and a nice flow for users to log in, because the email is kind of cumbersome, right? You have to pull your email app, maybe copy the token, maybe click on links. If it's on a different device, it's annoying because you have to retype the token. But with the passkeys, even on a different device, you can sign in nicely. One bit you need to do that I have not shown is that in our security configurations here, I said, well, we have these repositories that save passkeys to the database. So you need to configure your database to be able to save these passkeys. So if you want to find out what the table look like, you can go to these implementation, and in the Java doc tell you this user credential repository depends on the table definition described in user credential schema.sql. So you can go to that schema, and it will tell you all the things that you need. So maybe you want to adapt this to your database. For example, I'm using Postgres, so I'm using like text instead of using varchar. And so this table contains a bunch of things. The ID of the credential, this is how we detect which passkey is used. The user that owns this passkey, and then the attestation object. That's the big thing that contains all the data, the public key, and everything I need for security, and then some metadata. This is display things, right? So the name of my passkey. This is not in the spec. This is just us deciding, oh, when you want to see the list of passkeys, right, in here, you want to see when it was used, you want to see how it's called, so you have a label. And then a bunch of things here, a lot of data. So all of this is additional data that you may want to use to perform additional security checks or not. The basic security checks are all already covered by WebAuthN for J from this attestation object. And the reason why we give you this is because this data is in this kind of data structure. So that's from the spec. And all of this is like crazy, complicated data structures. So this is encoded with CBOR. Who knows what CBOR is here? Yeah? Compact binary, concise, not compact, concise binary object representation. So like a very packed data, so you can't read it. Then you have to read all of this and then traverse the graph, and then you get to this COSI key. But this is CBOR, so we put CBOR inside your CBOR. So you don't want to be touching that. WebAuthN for J does it for you. It unpacks everything, and we save it, right? Usually, you don't really want to be interacting with the attestation object because for example, WebAuthN for J, WebAuthN for J has this web authentication manager. So to validate a credential, it calls validate, which calls verify, which calls verify, fine. So it parses the data, then calls verify, which calls verify. It's Java, right? And then it gets into this giant method that says step 1, step 2, step 3, step 4. And so depending on the browser, some browsers do stuff, some don't. And then it calls verify for each step. This, you don't want to be implementing yourself, right? So we do it for you. So yeah, trust the machine. This is fine. And we keep maintaining that. OK, one last thing I want to show before I free you to go get your beer. So if I log out of here, right, this is not really production ready in the sense that if it's an internal app, this UI is fine. If it's your user-facing website for your company, you probably don't want it branded like this, even though it's a beautiful blue, right? I chose that myself. You probably want to provide your own experience. So let's do that thing, and like let's brand the Passkeys login as we like it. So I'm going to create a controller to serve a page. Passkey controller. OK, this is a controller. And then we do a get mapping to, say, call it custom login. Custom login. And then, sure, return custom login. Perfect. So now I have to create a custom login template, HTML, custom login. Right? OK, sure. And then I have to make that page public because by default, you're security conscious. So by default, all your requests are protected. So my new page, custom login, is now available. OK, and now we have to build that page. So how do we do it? Let's call it sign in here. OK, and then we make an H1, sign in, and then we make a button, sign in using passkey, right? I'm going to put an ID to that button. Sign in, passkey maybe. OK, so you've already noticed that I'm actually, yeah, reload, fine. I'm actually very good with UIs, right? This is beautiful. So our custom login also looks very good. But I want to make it a little bit snazzy. So let's put some style here, all right? So our sign-in button passkey. Oh, IntelliJ, yes, yes, yes. Let's make it nice. So let's say the font size is 2 rem, right? We want to make some padding, 20 pegs, sure. And then we want a background, linear gradient, say 2 top right, and then maybe we start from orange and we go to aqua. Yeah, right. Okay, yeah. Here we go, right? That's why you want to build your own passkey. Now, I think something's missing. Something I forgot, very important thing. Font family, Comic Sans. There we go, cursive, and then maybe sans serif. Sans serif. Okay, cool. All right, here we go. This is what we want, all right? Okay, so we want this button to sign in with a passkey. Now, we've done the important part. Let's do the boring part now. So we need some JavaScript. So script. And then we're going to be passing some values. So I will put some timely stuff here, th inline JavaScript. OK. In here, document. Yes, I would like to have auto-completion, but I can do that myself. Event listener, DOM content loaded. So when the page is ready, then I'm going to grab the button, query selector, the sign-in passkey, and then we'll put a sync handler here, event. Yeah, cool. Oh, wow, I can't type. There we go, and then this needs to be closed. And so when you click on the button, let's see, does that work? Hello, Devox UK, just to be sure that my JavaScript is still working. Yep, poop, not working, okay. Oh, I need to, wow, okay. Add event listener, right, on clicks only. On click, do this. Cool, this is better, I think. Yeah, and then a comma here, amazing. Okay, okay, cool, all right, first try. And so now we need to do the JavaScript for this. So you could go to the spec and try to understand what's happening there. Or create artist steal. So you go to localhost, you go to the main page here, right? And then you go to whatever tab is called in your browser here. And then you look for the WebAuthN.js file. And then you're going to steal all the code that's in here, all the way down to the authenticate method, or the register method if you want to register your passkeys. So we just do authentication. Beautiful, copy this, boop. So this code is Apache license. It's in Spring Security, right? Spring Security here. If you look for WebAuthN, core, right? All these functions, you know, authenticate, it's all there. You're free to copy it, put it in your project, and then change it as you will. So we want to call authenticate. So let's remove the alert. Sync, we want to await the authenticate method. And so we need to pass a few things. Headers, let's wait for a bit. Context path, if your Spring app is under, say, I don't know, internal or whatever, you pass a context path here. And then conditional mediation is complicated passkey stuff that we ignore for now. This gives you a redirect URL. So const redirect URL equals this. And so we redirect the user by doing window.location.href equals redirect URL. Okay. So the last bit we need to pass is these headers. What are these headers? You can find out usually, again, by inspecting how the app is built on the default login page. So go here, there's some JavaScript, and then you can log in, or you can, zoom in, and then you'll see this XCSRF token. CSRF, the bane of your existence. Do not disable CSRF. I know where you live. I will hunt you down. Use the CSRF token. It's easy to inject them in Timeleaf. You can do it in many ways, in whatever your setup is. So do pass those tokens. So get header name, and then you pass the value. So this is crazy Timeleaf templating syntax. Get token. I think that's about right, right? So we go back to this page, right? It renders. I think we'll have a CSRF token. Oop, right? CSRF token here. So now, let's channel my inner Josh Long. And then click here. Do you want to log in using a passkey? Boom, baby, first try. Woo! So, observation here is quite a bit of code, right? So even if you want to do that, it's going to be a bit complicated, even if you just copy the code, because you may want to tweak some things and it gets nasty. Also, it's JavaScript, so sorry about this. But it's the same, right? They have brackets and stuff. They just put, like, you can even take all the consts here and then change them to vars, and then it's fine. It looks like Java. Okay, so you have earned your beer after a few words from me. So it's a complicated topic. In most cases, you don't want to be implementing that yourself. Because, say you're using Azure Entra ID or like what's called Active Directory before, it does that for you. If you're using Keycloak to manage your users, Keycloak has a checkbox here. You can say, yeah, enable passkeys, and you push that to your identity provider. So user management does the passkey stuff, and you don't have to do it yourself. If you do have to do it yourself, please use the library, or like don't, but then you'll come back crying to me crying because it's awful. So use the library if you're in Java, if you're using Spring. Spring Security has support for this. As you can see, I didn't have to write any Java, just like the 4 lines of config, and then that's it. You will have to write some JavaScript though. JDBC support is coming in 2 weeks now, so you can save those passkeys. That's going to be fine. If you use them, we are eager for feedback. So please contribute. It can be code. It can be issues. So you go to the issue tracker and you say, oh, I want to support this use case. Or you can even look for a passkey or WebAuthN in the issue tracker. And then if you find an issue that matches your use case, you thumb it up. And a thumb up for us is a signal that, the more people want a feature, the more they thumb it up, the more we're likely to implement it next. And finally, if you like pain and suffering like I do, you can learn how passkeys work internally by going to Yubikey's website. This is probably the most human-readable website we have for describing passkeys, i.e. not the spec. So you can go to Passkeys and you'll see like how passkeys work, and they have the same kind of sequence diagram that I just explained. And for an implementer, you're doing WebAuthN, so you can go to WebAuthN, developer guide, and then they have all the details. Oh, here that the objects, and then you can use this JavaScript to register, blah, blah, blah. And so you can learn a ton from this website here. OK, one last thing maybe. Is it? Yeah, it's here. One last thing. If you want to play with the sample, you can find it on GitHub over here. Since you are all very, very strong security-conscious professionals, when a random guy posts a QR code on stage, what do? You scan it, of course. This is not an attack. This is the feedback form for the session. Please take 5 seconds to rate this session so people who see the next version of this get an even better version. And send me an email, reach out at the conference, grab me, interrupt my conversations, ask me anything. And I guess I'll see you at, I'll see you at the pub quiz or wherever. Thank you very much. All right, do you have any questions apart from wherein is the beer served? Yeah. Sorry, using passkeys, you don't? Yeah, you don't do multi-factor because it's built into the passkey, yeah? Yeah. Yes, so the question is, are passkeys really multi-factor? Because if I use, for example, a password manager, I'm just proving that I have access to the password manager. We do trust that your password manager is correctly set up for that. Also, in the awful diagram that we showed here, there's a magic bit here, user verification, that is set by the passkey that says user has typed in a password or done biometrics. The user has verified their identity. So if I try and register this device here that doesn't have a password, the flag would be off, and so I can treat it as a second factor only, right? I could say like, oh, I do not let you register this passkey, or I only let you use this passkey when you also provide your password. So it's possible. Most of the time, it's fine. I mean, if your password manager is easy to access, you have other problems than poorly configured passkeys. Right. So in here, in this attestation, there's a bunch of stuff, extra stuff that you can check. But depending on the vendor, this gets very into the weeds. So for example, the Mac here sends you no attestation objects. So it's like, don't care, I won't tell you. Right, if you're security conscious, if you're a bank, if you want your users to use like, biometric Yubikeys, that you can check. But for a thing that works for every user, it's more complicated. It's going to be more safe than just a password anyway. Cool. Thank you. Have a good rest of the conference. Thank you for your attention. Bye-bye.